Well, to figure out what this is in radians, all we simply need to do is use our unit conversions, unit conversion ratios. And if you guys look at this, if I want to take this degrees and put it in radians, that means I don't want to have any more degrees, degree little symbols, right? So I need to have the division property apply. That means I need to have the degree symbol in the denominator so my degrees will divide out. So I'm going to multiply it by pi over 180. So put that over 1. So now this multiplies to 120 pi over 180. Oops. Yep, so then you're going to have to simplify. Now the main important thing I want you guys to understand, do you guys see how the degrees divided out? I don't need these degree symbols anymore. One's in the numerator, one's in the denominator. They divided out. Yes? Yes?
The pi over 180, is that a rule you have to, is that a rule for like every problem?
Well, you agree with me that pi is the same thing as 180. You agree with me that 180 is the same thing as pi. So it doesn't matter. They're equivalent. Right? It's like taking a fraction. Think about this. Take a number. Let's take the number 3. And let's multiply that number by 5 over 5. You agree with me that 5 over 5 is the same thing, right? So when you multiply that across, you get 15 over 5. Is 3 and 15 over 5 equivalent? Yeah, they're exactly the same, right? So when you multiply something but that's exactly the same, you're just changing what it looks like. You're not really changing the solution, though. So pi and 180 are equivalent to each other, right? Just they're in different units. This is in radians. This is in degrees. So you're not changing the answer. You're just converting it from degrees to radians. Because now I can simplify this. I don't need the zeros. So I just do 12 over 18, which is 2/3. So my final answer is 2 pi over 3.
Okay. So now say if you had 120 degrees, say if you had 90 degrees, would you still use the pi over 180?
Yeah, always.
Okay, that's